Hi everyone, this is Preetham. Today I'm here to talk you through about the scalable framework for prompt engineering for safer and smarter LLMs. So before we get into the topic itself, a quick introduction about myself. So I'm Preetham Sunilkumar. I work as a vice president for LPL Financial, a wealth management firm based out of in Austin, Texas. And I've been actively associated with numerous research organizations, which includes ISACA, Raptors, Sigma, and did published research papers in the area of software engineering and AI. And today's topic has been recorded for Conf44 Prompt Engineering Conference. So where we will be empathizing on engineering intelligence, not just instructions. All right. With that said, let's quickly have a deep dive into our agenda, what our agenda looks like. So, first, we will be talking about the hook, the prompting paradox, and the problem with the craft, why the craft doesn't scale. And we'll be introducing a new framework, which I call it as a prompt constitution. And today, we're going to go in detail about three basic pillars, which is very key, essential. The pillar one, structural integrity. And pillar two is a safety net, and pillar three is scalable assembly. And probably I'm going to run you through on how this entire constitution prompting works and few advanced methods to evaluate the prompts and the LLM capability as well. And finally, we get into a conclusion. So pretty structured agenda for today's topic. Moving on, we'll start with the hook, the prompting paradox. As you see on the screen, two different images. The first images is think about a magician taking rabbit out of his hat, right? Looks like pure magic, right? On the other side, you have complete chaos contracts, right? Where things are not structured, very unstructured, or it's becoming quite difficult to make it a linear or structure or meaningful data, right? Basically the chaos representation. So now let's take these two images and compare with our LLM, right? So today, a few words to any LLM, right, will give you an immense knowledge and creativity. It's just like a pure magic, right? The rabbit coming out of the hat of a magician, right? But think about the same model, but little tweak in your prompts or little tweak in your user inputs can produce an dangerous nonsense, which is completely madness. Think about the chaos which we called out on the right side, right? So this is exactly the prompting paradox which we're talking about. Has LLMs is having the immense power trapped in it, but it can provide us unpredictable craft. Let's take a few examples. We just don't want to spend more time on the slide, but just want to give you an example, right? You can say generate a web app like apple.com or provide me the insight into the company's performance or based on the data sets, provide me the investment ideas, right? So today the LLM can do that for you, right? It can give you all the inputs, all the insights, so on and so forth. So similarly, if you change a little verbiage of it, instead of saying generating a web app like apple.com, you say generate an Apple web app. The output is completely different, again, based out of context as well. So today we are moving from the artistic view to the industrial view, right? And see how we can resolve this prompting paradox. All right. With that said, let's move into why this crap doesn't work, or what is the problem we are facing with this unpredictable challenges with LLM's output, right? So before we see the three walls, which is quite important, but we want to talk about the traditional system first, right? So our tradition systems were always like deterministic systems, right? Which is basically works out of your business logic or your set of rules which we have derived. So you send a sequence of inputs, it just gets to your business logic, and finally you get into the output. It's very deterministic in nature. But whereas in LLM, it's completely unpredictable behavior, right? There's no logic or there is no like systematic structure in place. And if you look at the way the LLM being applied, the LLM being productionized in critical domains like healthcare, finance, as well as education, right? As this domain start adopting the LLM, the output of this particular LLMs is a key role, right? We want unbiased content delivery, Though this LLM is very powerful, but it does exhibits the non-deterministic responses, biases, vulnerabilities, and whatnot, which we already aware. So if I want to group all of them into three walls, which categorizes all the issues into it as the safety wall. So the safety wall basically includes prompt injection. So you guys already know what's prompt injection, but in a quick overview, in a prompt injection, basically an malicious user crafts an attack, right? To override the original instructions given to the model, or we might ingest a new commands, or misleading the entire context, or tricks the model into revealing restricted information or performing unintended actions. So the prompt injection is part of the safety wall, and the jailbreaking. The jailbreaking again looks like tricking the model into ignoring the safety rules what we have built in, or get the model to generate prohibited content or access data, right? Which is not intended to be going out. That's all together combined into a safety wall, prompt injection, jailbreaking, and biased outputs. And the second key wall here is the consistency wall. When we talk about the consistency wall, we won't get the right results every time. With simple bit of change in the phrasings, you get altogether a 180 turn output. So basically, this refers to how different ways of asking the same question can lead to different answers using LLM. So let's take an example to prove what is this consistency I'm talking about. So the prompt A and me doing a prompting, I'll ask what's the best way to learn Python, right? And in the next time, I ask how should a beginner get started with Python programming? In my view, both ask the same thing, but the model might recommend different resources. It emphasizes different learning styles, even contradict itself in some cases, which we all of us haven't seen. So why this happens, right? The LLMs are sensitive to wording and context. We already know all of that. They don't understand meaning the ways humans do. They predict text based on patterns. The slight changes in phrasing, the way we did in example prompt A and prompt B, can activate different parts of the model training data as well. So that's the consistency wall as we hit with this LLMs. And the third important one is the complexity wall. Though it looks like very simple, but when you productionize your system, this wall plays a major blocker or major hurdle. So think about we generating numerous prompts, right? Prompts on top of prompts, prompts on top of prompts to derive one of the derived output of the LLMs, right? So what we try to do is we try to do too many things at once. That's how I've learned my initial prompting. And I used to include nested instructions, conditions, or role playing, everything combined together. And it was lacking the modular structure or clarity. And it's hard to reuse, debug, or scale which part of my instruction is not working or deriving the different results. So it's very important that we answer that in our framework. In a simple word, the complexity wall, which I'm talking about, is with our current methods, we are building like a skyscraper with sticky nodes, right? Without any structure in place. So that's the complexity wall we are talking about. This is the three walls we hit to craft why the craft doesn't scale, why our LLM craft doesn't scale. So before we get into the solution, I want to just run through beyond traditional benchmarks, right? So our traditional benchmarks, we all know it's on rule-based or business logic-based, right? But whereas evaluating LLM, we need modern evaluation framework. We all agree. So why do we need modern evaluation framework? To address the challenges of generative AI, which are non-determinism, emergent behaviors, contextual understanding, so on and so forth. So this is exactly has why we need an AI framework which provides safety, reliability, and trustworthiness. So just want to give you a bit of context between the traditional benchmarks as well as the LLM, and to prove to a point that why we need a framework, right? So now let's talk about the framework, right? So in today's topic, we introduce something called as prompt constitution. Think as a very similar constitutional rules we all abide to, right? Baking ethics in the evaluation is the key, right? So this prompt constitution paradigm achieves most modular, reusable, and verifiable framework that structures human LLM interactions, right? So the whole constitution is based on three basic pillars, and absolutely we look into the more advanced concepts as we move along. So the three basic pillars are structural integrity. Why do we need structural integrity for smarter LLMs? And the third is safety nets. Why do we need the guardrails for safer LLMs? And probably we'll talk about the scalability assembly for scalable framework. So this is exactly the three problems which we have seen in why craft doesn't scale, the three walls we spoke about. So similarly, the Constitution addresses these three walls with the three pillars. The pillars are structural integrity, safety nets, and scalable assembly. So now we'll deep dive into those three basic foundations, which is very important before we move forward on some of the evaluation techniques. So the part one is, or the pillar one, which I call it, is a structural integrity. So the whole idea, what the structural integrity brings in is stop using one chain perfect prompt. So we are breaking our prompt into a complex task, right? Whatever the complex task we have, we're going to break it down into a chain of specialized and simple steps. So the idea is to create most modular, most testable, most reusable components. So think about this us building a single story house, right? We won't do it everything on the day one or everything grouped into day one, right? We start with the foundation. That's the decomposing. We start with the foundation, then we go layer one, layer two, layer three, then we'll finish everything together. So decomposing dot for clarity and control is the call of action in the pillar one, right? So we spoke about what it is, but let's take a look at it in real example right here. So I have a simple LLM which performs a basic task. And the task is something like this, right? It basically analyzes the customer review, saying I'm using any product as a customer, I provide the review. So it needs to analyze the customer review for the sentiment in which I'm expressing it and what the key topics I'm talking about and suggest back me a response, right? So instead of human, we want our LLMs to do it, right? That's a simple task. Now let's look at the whole way or monolithic prompting way we used to prompt this to our models, right? Or I used to do it in starting off my journey, right? Or my prompt journey. So I used to call it as, hey, read this review and tell me the sentiment, the main topics discussed, and write a customer service response. I was very happy. Hey, I given kind of a very good prompt and model is taking in and it's giving me sentiments and analysis. As I move along, I've learned as this is not the right way of prompting. I need to break it down. I need to have a structure in place. How did we learn? When we move like 100 reviews, 200 reviews, 300 reviews, then you start seeing model being biased. Model was giving you the outputs which is not intended, or so on and so forth, right? The accuracies is in question, so on and so forth. So in order to resolve the issues, and we recommend as part of the filler one, so it consists of basically a router which classifies the task, right? What task needs to be done by which specialist. So in our case, for this task, we have three different specialists. The specialist A basically determine the sentiment of this text. It basically analyze, the review and gives you an output of a sentiment which is coming out of those texts. It won't do anything more than that, right? Then absolutely we will be having an evaluation model, which we'll talk in detail as part of our constitution, which will evaluate the output coming out of each specialist. But for now, let's think that specialist A, which will just determine the sentiment out of the text, right? Then we're going to have the specialist B, which is chained workflow, which basically lists the key topics and the concerns which is coming out of that particular review, right? It just lists down, okay, here is the topics which has been discussed about this particular product and these are the concerns. And specialist C, right? Given the sentiment, which is an output from specialist A, and given the topics, which is output from specialist B, it will draft the helpful responses which needs to go out to our clients. So what is that we achieve out of the structural integrity or creating the different specialists and linking all together to a workflow, which evaluation at the each stage gives us more accuracy, more control, and each component is reusable for other tasks. Think about tomorrow, you're going to set up one more LLM which does need a topic extraction. So you need to rebuild all the way again, use a specialist P. Similarly, in one of your other projects, you need a sentiment analyzer. Here we go, you have a specialist A which you can reuse it. So that's the part one, the structural integrity. It's very crucial. Then moving on to the part two, the guardrails, the safety nets, right? So the whole idea is being proactive defense, not reactive filtering. That's the takeaway out of the pillar two, right? So the idea is instead of us just validating the output the model has generated or the LLM has generated and filtering out certain part of it and giving to the client, this is not the desired way we want to go ahead. That's exactly one we need to avoid as part of the safety net. We need to engineer the safety nets all the way throughout the process of an LLM, right? To be inherently safer, right? So building safety into the prompt architecture is what the pillar two is talking about, the safety nets, right? So again, let's talk about an example. It will be very useful when we run through an example rather than talking with the words here. Same. Let's take the same scenario the way we had earlier, but now we're gonna talk about the service bot. So a user asks a customer service bot, right? Basically, a financial nod. You ask details about your banking, and gonna respond you back. So now user ask a question. Hey, my account was charged incorrectly. Also, how do I hack into someone else's account? So, as part of the first topic I call about just filtering the output, so this entire user input goes to the LLM as it is and derive the output. Then you look at the output, then you filter it out certain part and send it to the user. But this guardrail going to introduce something called as preprocessor before this goes to your actual processing engine or your LLMs. We will set up a pre-processing guardian. It can be another LLM you're gonna build, another agent you're build, doesn't matter, but have a pre-processing guardian which basically analyze the user query, any request coming in. For example, let's look at this particular user task. My account was charged incorrectly. So your pre-processing guardian takes this, okay, my account was charged incorrectly, excuse me. So that's a valid ask which my customer service bot needs to answer, right? And it looks the second phase of it also. How do I hack into someone else's account? Then that's a clear violation, right? My pre-processor guardian will flag it for the violation and say that, hey, I can't consume the second part of the statement here. Then the safe responses will be generated. Hey, it takes the first one, which is important. It says that I would be happy to help with the billing issue on your account. That's why I'm intended to, right? The model is intended to do that. But it's saying regarding your other question, I cannot provide guidance on the topic as it violates my safety policies, right? In that way, your LLM never talks to any data or any account. The pre-processing filter out what are the valid actions, what are the violations. And it's just pre-processing at the stage one, but you can have the safety net at each and every layer of your entire agentic solution. So the benefit what we're going to get out of is the harmful query is neutralized, as we have seen in an example, before it even reaches the core response generator, right? So baking in ethics from the start of your solution is a key safety net pillar which we need to build, right? All the way till to the output, just not filtering the data generated as part of output response. So that's a second pillar. That's a takeaway out of the second pillar. Now, moving on towards the pillar three, which I call it a scalable assembly, the connectors. So this purely talks about how we maintain our prompts, though it looks simple or it looks, hey, we have a Git, we maintain version, we maintain prompts, but it's very important. We treat each and every prompt as a software component today we build, right? We version them, we test them at each unit level and integration level and whatnot, right? And we compose them. So make sure that the way the software is delivered, you have CI/CD pipeline, you have E&B testing, right, between version 1 and version 2. And always when we deliver software, we are optimistic that it will work, but in the meantime, we prepare for any failures, right? We prepare for the failures to roll back. You have feature flagging concept today, right? Or you roll back the complete build automatically as part of the deployment. The same logic needs to be applied for the prompting. So that's the scalable assembly we are talking about. So the idea is we differentiate your catalog, basically your prompts, your sentiment analyzer prompt, your topic extractor, your Guardian constitution, and the whole architecture engine which runs those prompts and gives us the results is a complete subset. And we version each and every prompt or each and every phrase we change in our prompts, right? So in that way, if tomorrow we want to roll back, hey, V1 was working fine, the V2 is not working, you just roll back. It's as simple as that. You're using cloud model and you have 4 sonnet and you got 3.x sonnets. So 3.x is deriving you more results and you want to roll back from 4 to 3.x, which you can do it. The similar concept or component needs to be applicable for each prompt we build. So what the benefit we get out of it? The complete stability and maintenance. If we think things are not working in production, after all your EAB testing or CI/CD, it's very easy for us to swap to the previous version and move forward. So that's exactly what we are talking. And make sure the library in which is a catalog, that's where all your versions are defined. If you want to do a rollback, it should be just one line change. So these are the 3 foundational pillars which we recommend to follow as part of constitutional prompting framework, right? Now let's take a look at how this constitution work, right? The constitution prompting or framework starts with defining the constitution. So you define your own constitution. So based on your organizational values, right? Your regulatory requirements. If you're working in finance, you might be entitled to FINRA regulatory. If you're working in healthcare, you might be entitled to healthcare regulatory. And on top of those organization values and regulatory requirements, the key important pieces: what are your ethical principles? What are your behavioral guidelines that your constitution should abide to? So that's the first step. Define your constitution. And the second one is self-critic your output, your LLM output, your prompting output at each stage. So the idea is at each stage, every model output is evaluated against what? Against the defined constitutional principles we did in stage 1 and identify any potential violations or misalignments, right? So that's the phase 2. Define your constitution, have it self-critic, bake in your self-critic as part of your pipeline. And the third one is revision. As you do this critic, as you define your constitution, you just see there's a lot of areas where you can generate improved responses. You can be more safety. You can implement better constraints. So that's the revision, right? As I said, treat your prompt as code, structuralize it, versionize it, and move on. And finally, very key is reinforcement. It's very important that we give feedback to the LLMs, what we are building, or give feedback to the prompts which we are sending, or give feedback to the racks, what's been implemented, pulled over in a complete holistic view. And this feedback should be learned and self-healed, self-evaluated, whatever the reinforcement techniques you want to define, we need to define as part of this constitution. So the constitution works out of the 4 ways. Define your constitution, have it self-critic, have it revised, and make sure you have the feedback going in as part of reinforcement. All right. So now I'm going to talk through a few of the evaluation. What are the key objectives when we want to evaluate it, or when you want to do a self-critic, or make sure your prompts are deriving the right results after you're applying the 3 structured pillars. So the synthetic data generation is very key, right? What kind of data has been evaluated against the model or agent you're building? So before we define the data, I recommend we need to define the evaluation objectives, right? Generate your data, fair enough, but before generating the data, define the evaluation objectives, right? You are generating the data to evaluate what? Is it for factual accuracy? Is it for reasoning ability? Is it for bias? Or is it for fairness? Is it for robustness towards the advisory inputs or instruction following? Or is it due to the multi-turn dialogue coherence or safety and refusal behavior? It might be any one of these evaluation techniques. Make sure you define the objective of this evaluation and create the synthetic data those particular criteria. So you can use LLMs to generate synthetical inputs, right? Or you can have your own set of question answer pairs, which you think is generically coming in, or you create your own paraphrase prompts to test consistency or simulate the user personas. So these are the kind of synthetic data templates you need to define for each evaluation techniques. And once you have the data generated, try to label that synthetic data, which is a key. Is it rule-based data? Is it for which model to evaluate? What are the synthetic data generated automatically or semi-automatically? So you can use that labels to correlate the data what you are generated for. And finally, it's very important to evaluate this metrics again as the systematic approach of identifying the criteria and building the test data against each criteria, and finally evaluate the metrics for them, rather than just creating a set of 10 or 15 questions which has been reused, or which are the questions you want the model to answer, and just go test them and pause and productionize it. Yeah. It's very important that you understand the evaluation criteria and synthetically generate test data for all of them, then evaluate the metrics, right? So that's the key for the evaluation, the data generation. And the next part is red teaming. I don't know how many of you heard about this red teaming and advisory evaluation. This is very key. Think about the similarity ethical hacking. Today, if you're building any systems, right, any login functionality or any simple financial system or banking application or e-commerce application, you do ethical hacking, right? You do SQL injection, you check for the top security issues out there and whatnot. So the same thing, the red teaming is a process which involves intentionally probing the model to uncover vulnerabilities, biases, unsafe behavior that can be exploited or cause harm in real world use. So there are 5 concepts I just want to stress upon and make sure that you include this as part of your red teaming. One is the threat modeling, right? And the second one is advisory generation. Third one is stress testing. And the fourth one is vulnerability analysis. And absolutely make sure iterative hardening is part of this process. So that we spoke about the red teaming. What is that we're going to achieve out of this red teaming capabilities? Just it will help us to uncover all the hidden risk, or uncover the hidden risk in your prompts, in your LLMs, and in your outputs. I've just given a basic difference here. Conventional testing messes rate but critical failure modes, but red teaming reveals prompt injections, your training data leakage, alignment failures, brittle behavior, and systematic biases. It's very key that you include red teaming as part of your constitutional principles. All right. So then I want to touch about the last point before we conclude here. The regulatory compliance is a key, right? Based on your organization, industry alignment, right? If it is finance, it is banking, it is educational, it's medical. We have different regulatory compliance. And in terms of data, we have altogether in different data regulatory. And especially for the Europe, we have EU Act. If you already know, there are certain standards which you can take from them. Make sure that you include that. As per UAI Act, any non-compliance carries substantial penalties up to 30 million or 6% of global annual turnover. So it's very key that you bake in the regulatory compliance. So I just want to call out few key compliance requirements which UAI Act has called out, which basically underline into the 6 categories: your risk management, your data governance, your technical documentation, transparency, and human oversight. We're going to talk human in the loop as the next point. That's very key, and accuracy and openness. So make sure to bake in the regulatory compliance as part of your constitution framework for prompts, right? Then finally, I want to talk about is human in the loop, critical feedback mechanism. We all know the LLMs are powerful, but not perfect. They can hallucinate facts, they can misinterpret intent, they can amplify the bias, or they can fail in the edge cases. So human in the loop, so I call it as HINO, bridges the gap between the model capabilities and real world expectation. So what do humans do? Humans correct outputs, humans guide behavior, human in the loop evaluate for performance, human in the loop will enforce ethical and safety standards. So it's very important to have the critical feedback mechanism through human in the loop. And holistically, whatever we have spoken today, the multidimensional testing framework you're building should define your success criteria, should define your layer evaluation model, should implement your constitutional AI or constitutional framework or prompt framework at each and every level, and establish continuous monitoring, document everything, and build expertise. So, with that said, I just want to conclude with 3 points right here. So, the first point is the constitutional framework, the prompt framework, which we spoke about, help us to move away from being the wizards, prompt wizards, to be a prompt engineers, right? So, how did we solve that, or how do we achieve the prompt engineering? By bringing in the constitutional three pillars: structured frame for smarter LLMs, guardrails for safer LLMs, and the connectors, which is pillar three for scalable framework. And after the pillars, we have learned about the constitutional prompting, the systematic data generation, red teaming, which is ethical hacking, and even in the loop evaluation criteria. So all this needs to be done to ensure safe, transparent, and trustworthy AI at scale. But at closing, the third point, so let's stop being prompt wizards and start being prompt engineers. Let's build constitutional prompting for a smarter, safer future with AI. With that said, thank you for spending almost like 20 to 30 minutes with me. You have a nice one. We'll meet again. Thank you. Bye for now.